In the process of human development, the use of solar energy marks a very important milestone. Since then, mankind has used more and more energy, especially in recent centuries. In the current energy structure, the main part is bio-residual energy, coal, oil, and natural gas. Next is hydroelectric power, nuclear energy, biomass energy, gas, solar energy, wind energy accounting for only a modest part. Human society thrives without energy. Today, bio-residual energy, non-renewable energy, is increasingly depleted. Oil prices are increasing, adversely affecting socio-economic development and living environment. Finding alternative energy sources is the urgent task and ensure alternative energy that must be clean, environmentally friendly, low cost, inexhaustible, renewable, and easy to use. Renewable energy, including solar energy, has been studied and used by the whole world. In the world, developed countries have had many applications in life and in industry to obtain these energy sources. With the advantage of being readily available, abundant, clean and environmentally friendly, solar energy is an alternative to other energy sources that are being depleted on Earth. Humanity has long dreamed of using solar energy, almost inexhaustible source of energy, meeting most of the above criteria. Many studies have been done. Solar energy is not only the energy of the future but also the energy of the present. Currently, solar energy has been exploited and put into applications in life as well as in industry in many different forms and uses, usually for heat and electricity. A solar panel system using basic solar energy consists of two types: a standalone solar panel system and a grid-tied solar panel system. The main content introduced in this project only studies the components in the solar system that work independently. The project presents an overview of a solar cell system working independently with all the necessary components in the system. After that, the project focuses on researching more deeply into solar power sources including solar cells, control methods and algorithms to clearly see the working characteristics, advantages and disadvantages, applicability of control algorithms. For the solar panel system to work optimally, the objective of the Solar Panel Navigation System project was to fulfill the requirements of MGMT 2002 Project Management and Technical Report course as a part of the project, as well as developing skills in managing a project, proposals, designation, project creating charts, Gantt chart, decision matrix, WBS, SOW, logbook, technical writings, resource management, critical path reports, progress reports, presentations, also planning for budgets, risk assessments, time, scope. Secondly, apply all the gained knowledge in electrical engineering technology program at Georgian College and co-op experience, manufacturing and power systems, practice into a specific technical project, which includes knowledge of electrical energy, electrical circuits, electronic circuits, microcontroller, programming, robotic, PLCs, electrical system, working principle of motors, Ohm's law, Faraday's law, Watt's law, Newton's law of motions, Joule's law of electrical heating effect, safety. The third reason is to promote and develop creativity and enthusiasm for students, obtain feedbacks teachers to gain more experience and knowledge for the future projects in terms of design, function, form, structure, materials. The final reason for the project to be implemented is the functionality, operability of the project and capabilities of builders. The goal of the project is to show the importance of optimizing the performance of solar panel. When popular energy sources such as hydroelectricity and thermal power are increasingly depleted, the production of electricity by hydroelectric plants. Power plants, thermal power plants cause environmental pollution and change the ecological environment. While the demand for electricity is increasing, people need to find new energy sources to meet their needs. Solar energy is one of the solutions, found to be an alternative, with the advantage of being a clean, long-term energy source, a renewable energy source, environmentally friendly, and safe to use. Along with that, with automatic navigation to absorb sunlight, efficiency will be improved and enhanced, in which, with the same size of solar cell, 332 by 205 by 17 mm, 10-watt capacity, 16 voltage, 0.8 kilograms weight, an operating temperature from 10 to 85 degrees Celsius. The efficiency of solar panel navigation is reach more than 36% compared to fixed solar panel, leading to accomplish achievements of useful solutions, which help to gain an asset for future career. The goal of the project is also to meet the project completion time, specifically with only 10 weeks out of 14 weeks of the semester, including the first week to present ideas to advisors, the next 1 week to design electrical drawings on AutoCAD, SolidWorks and run simulations, the next 1 week to collect parts such as solar cells, frame, Arduino, light sensor, power inverter, power storage, motor. The next 2 weeks to sub-assemble the basic parts and write the program for the controller. The next 2 weeks to complete the project assembly, load the program and test, run. The next 1 week to test, and modify, then next 1 week to complete the final project. The final week used to prepare reports and presentations. With resources coming from students' budget, estimated at $650, along with other resources from labs and advice from mentors and teachers such as 3D printers, megers, DMMs, tachometers, etc. The project will be mostly built at the builder's personal place. Within the first 7 weeks, the last 3 weeks will be tested, modified and examined at college's labs, under supervision and suggestions of the teachers. The scope of the project depends mostly on the weather conditions. The project can only be tested, modified and officially operated in ideal condition, which is sunny day. In addition, the project is likely to have a time limit if it goes beyond the plan by 1 to 2 weeks because of testing, modifying. If so, it will conflict with the time of the course in the college because it is final test weeks. Besides, the estimated cost of the project is quite high, $650, along with human resources for building the project while attending the college. Modeling a solar panel navigation system is just only for learning and research, is not available for commercial use because of the size of the project. One of the constraints of the project is that because of the large number of components, it is necessary to consult many technical documents and advisors, mentors to ensure operability and safety when connecting and operating them. There are constraints that are out the control such as pandemic outbreaks, strike, college facilities and equipment limitations. There are solutions for constraints that will be considered such as replacing sunlight with artificial lights as lamps, phone's flashlight. Performing steps such as planning, creating drawings, collecting components information from as soon as possible. Specifically, it is possible to start now to be able to extend the project time. The project's budget can call for funding, pre-registration for tools and equipment as well as labs in case of overloading requests from other students. Refer to available models or versions to supplement building and operating knowledge. The project will ensure 5 phases including concept and initiation, research and planning, analysis and design, development and implementation, conversion and close. The project will be approved and implemented with a minimum cost of $650. Performed by 2 builders implementing this project, and both are equipped with PPE, safety materials. In which the project cost will be split in half and shared, will be spent for components in the second week of the project plan. Additional steps, stages, and ideas will be performed by both students from drawing electrical drawings, models, to gathering components, assembling, testing, modifying, making report, presentation. The project will be built in the first 7 weeks at a personal place and 3 weeks later at the college lab with support from advisors and teachers, mentors in professional and technical areas. The operational phases of the project must be ensured under sunny conditions. The facilities will be used as 3D printers, measuring and testing instruments. Electrical and electronic components must be 100% brand new, function properly and safe to use. When operating or performing for the presentation, there is no need for supervision by under-union workers. The project must perform the expected function and performance, ensure safe operation and use. After completing the operation for presentation and technical report, the project will be further researched and developed to be able to market or donate to the curriculum and teaching. Here is the cost estimate for the project, including the main components like 2 of 32 mm by 205 mm by 17 mm solar cell, total $90. 2 for 80 Mega 328 microcontroller and Arduino Uno, R3, $60 total. 2 of insulated wire per foot, $40. 4 push buttons, $20. An electrical panel for $30. 2 of Adafruit BH1750 light sensor for $20. 2 of 133*70*35 mm solar charger controller for $50. AR88ACAWA005B de Omron servo motor for $80. 2 of most expensive parts along with 8 of 14 Aruban Florins wire for $96. Aluminum frame for $55. Electrochemical storage, battery, for $45. A power plugs and sockets for $20. 2 switches for $20. 4 of variable resistor for $20, and the total cost estimate for the project is about $655 excluding wages.